All right, let's do some Mathity-Math. It says here, add the vectors. So we have vector C is 2, 7, and vector D is 16, 4. And then it says, and then find the resultant vector. So if you think about these like forces, it's kind of saying if this force combined with this force, what would we get? What would happen? Uh, and when we look at these, the way we combine them first is we combine the x forces or the x values, and then we combine the y values. So if we first combined the x values, you know, you're adding 2 and you're adding 16. So if you add 2 and 16, they would combine to form 18, right? Pretty straightforward. And if you do the y's, which are 7 and 4, if you add those up, you would get 11. And what this does here is it kind of says, well, there was a force pushing 18 on the x-axis, and there's a force pushing 11 on the y-axis. And so to see that vector and find that resultant vector, what you want to do is actually just build a triangle, and we'll find that hypotenuse. And that hypotenuse would be the resultant vector. So here, let me just draw this quick sketch, and this will make a little bit more sense. Okay, so here we have a classic XY coordinate plane. All right, so if we go 18 over on the x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whew, close call. Okay, so we went over 18, and this says go over 11. 1, 2, 3, oh, excuse me, up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So where if we go this spot right here, whee, there we go. You did it. That would be the resultant vector. That doesn't really tell us much. That's why we have to actually do some math. But as we set this up, we want to kind of see where our shapes and diagrams come from. And if you look here, what this does is that actually literally creates a nice little right triangle. So if I'm going to draw a sketch over here of this right triangle so we can kind of see it a little nicer here. So we have our nice hypotenuse. And so if this force went over 18, you know this side length is 18. And if this one went up 11, we know this side length is 11. And because it makes a right angle, we have a lovely right triangle. All right, so when we're trying to solve problems that have right triangles, typically we go two places, either to the Pythagorean theorem or to right triangle trigonometry. And in this case, because we don't have this angle or this angle, and just to keep our life simple, let's just go to the good old-fashioned Pythagorean theorem, okay? So Pythagorean theorem says a squared plus b squared is c squared. Okie dokie. Let me scoot down a little bit. So we can say this is a, this is b, and our hypotenuse would be c. So really, all we have to do is plug in. So let's do 18 and 11, and we still say, okay, well, that will be c squared. Okay, 18 squared, if you punch in your calculator, you'll get 324. And 11 squared, you might know this one, or you can use your calculator, you get 121. And then again, that all equals c squared. Let's come on down. Got some room to work. All right, lovely. Okay, so now we just add these together. Those are two constant terms. So 324 plus 121 gives us 445. Right, okie dokie. And so now to get rid of a square, we just take the root. So we'll just take the root of both sides. And you're going to find that c equals, and if we round this, we'll get 21.1. And there you go. That right there, that 21.1 is, oops, this hypotenuse, which is this resultant vector. There you go. Good job. Okay, as always, go ahead and subscribe if you want to be notified when I make a new video. And you can leave a comment or a question below, and I'll do my best to answer it or make a problem that you want to see. Thank you. Bye.